Calling Azure OpenAI from Python looks like 3 lines of code, but a production setup is a small architecture with real decisions baked in. In the next 5 minutes, we'll dissect that reference design, how a request flows from your Python process to a deployed model, where authentication fits, how to write the actual client code correctly, and the failure modes that bite you under load. By the end, you'll know what every piece is doing and which trade-offs an architect weighed. Let's open the diagram. Here's the shape of it. Your Python application runs somewhere with an identity, often Azure Container Apps or a function. It authenticates through Microsoft Entra ID, gets a token, then calls an Azure OpenAI resource. Critically, you don't call a model directly. You call a deployment, which is a named instance of a model like GPT-4o that you provisioned in that resource. Key Vault holds any secrets you can't avoid. This separation is deliberate. The resource is your network and policy boundary. The deployment is your capacity and version unit. First real decision. How do you authenticate? The quickstart path is an API key, a static string you stash in Key Vault and pass as a header. It works everywhere, but it's a long-lived secret you have to rotate and protect. The architect's preference for anything running in Azure is managed identity with Entra ID. Your app gets a token automatically, scoped by role-based access control, with no secret to leak. The rule of thumb: use keys only for local prototyping, and use managed identity in production. Grant the cognitive services OpenAI user role and you're done. Here's the code that ties it together using the official OpenAI package. Notice we pass a token provider built from DefaultAzureCredential, not a key. The endpoint is your resource URL, and the model argument is your deployment name, not the base model name. That last point trips people up constantly. The API version pins the contract, so set it explicitly and check the current docs for the latest stable value. From here, response.choices gives you the completion. This same client handles streaming and async with minor changes. Walk the path of one call. Your code requests a token from Entra, which is cached and refreshed automatically by the credential. The SDK sends the chat completion to your deployment's endpoint. The request passes through Azure's content filter on both input and output before and after the model runs. The model generates tokens, the response comes back, and your app reads the choices. Every step here can fail independently, which is why understanding the order matters when you debug a 403 versus a 429. Now the failures. The big one is HTTP 429, too many requests, when you exceed your tokens per minute or requests per minute quota. The response carries a retry-after header. Honor it with exponential backoff rather than hammering. The SDK has built-in retries, but tune max_retries for your traffic. Watch out for context length errors when prompts plus completion exceed the model's window, and content filter rejections that return a specific finish reason. Token expiry and transient network errors round out the list. Log the request ID from response headers so support can trace a specific call. The last architectural lever is how you buy capacity. Pay as you go, the standard tier, bills per token and is perfect for spiky or low volume workloads, but your quota is shared and latency varies. Provisioned throughput units, PTUs, reserve dedicated capacity for predictable, low latency, high volume traffic at a fixed cost, whether you use it or not. The rule of thumb: start standard, measure your sustained tokens per minute, and move to provisioned only when volume justifies the commitment. Pricing and quota defaults change often, so check the current Azure docs before you size anything. So the full picture: an app with an identity authenticates through Entra, calls a named deployment inside an Azure OpenAI resource, passes a content filter, and reads back choices, while you plan for rate limits and choose a capacity tier that fits your traffic. Your one concrete takeaway: wire up default Azure credential and a token provider from day one instead of an API key. It costs you nothing extra in prototyping and saves a painful secret removal refactor before production. Pin your API version. Check the docs for current values, and you've got a setup that scales from quick start to real workload. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.